Grade 12 Physics, Energy and Momentum Note number 10, Angular Momentum. This note is about looking at momentum at something going around in a circle. So the variable we use for that is an L. L equals the momentum cross product with an R. If we expand that momentum term, M times V, so we get L times mv cross R. You can read in your notes what exactly a cross product is. It's something you might see in vector calculus later on. The classic example here is a figure skater. Angular momentum needs to be conserved, meaning it's going to hold a constant value even when things change around it. So if L holds constant, if we look at a figure skater with her arms out, this is a fairly big radius. She's going to spin around with a smaller velocity. Once she pulls her arms in, she's effectively reducing the radius, but angular momentum is conserved. So if we're going to calculate the same value for L, and if R goes down, something else has to increase to compensate. Here, the velocity will increase to make sure we get the same value of angular momentum. And this is what we see at the Olympics. When a figure skater pulls her arms in, she spins a lot faster. It's basically conservation of angular momentum. So an example here are shear pins on an airplane. Pretend here we have an airplane flying directly out of the page. There's two engines on the airplane. The engines have a lot of angular momentum. They're spinning at high speeds. If for some reason one of them were to suddenly stop, one of them were to suddenly jam, instead of having a small radius on that engine with the fan blades turning, what essentially happens is the entire airplane, the radius is increased, and that angular momentum will want that whole airplane to turn over upside down, which is bad, especially for a passenger jet. So if that radius is increased, that speed of that airplane turning around will essentially be decreased, but nonetheless it'll turn over. So instead what happens is on top of each of those engines, if for some reason it were to suddenly jam, two shear pins would break and the engine would fall off, and the airplane would just return on the other engine. So these are safeguards because of this conservation of angular momentum. Second example is a small windmill. So these are windmills used to generate electricity. They have weights on the back of the blades that are able to move towards the center or away from the center. Now these windmills need to spin at a certain speed, but we know that wind blows at different speeds all the time. So these weights move in and out, which effectively change the radius of the windmill, and by changing the radius they can make it speed up or slow down just like a figure skater. So if the wind is high, the weights will move out to essentially slow it down. You increase the radius, so you decrease the velocity. If the wind's too low, the weights move in so that radius is decreased and velocity